Today we're going to review for the fall midterm exam. On this review, there are 9 problems. That means that on our exam, it's going to follow the exact same format. You'll see similar problems to this. All right, let's begin. Number 1, find the inverse function f inverse of x for the given function f of x. So f of x equals 3x plus 4. We have to do a few things here. The first thing we have to do is we have to change f of x to y, so it's just a little bit easier to work with. So let's say y equals 3x plus 4. Next, I want to solve for x, so I want to get x alone. So let's subtract 4 from both sides here. Okay, this is going to give me 3x equals, and then we'll write y minus 4 over here. And then let's divide by 3. Okay, I've now solved for x. X equals y minus 4 over 3. Now to actually find the inverse, I'm going to swap x and y. So where I see x, that's going to become y, and where I see y, that's going to become x. So this will be y equals x minus 4 over 3. And then we're going to put this back into function notation, except I don't want to just say y here. I want to say f inverse. So not just f, but f inverse. So that'll indicate that this is the inverse function of x, f to the negative 1 of x, equals x minus 4 over 3. All right, number 2. Show that the functions y equals negative 3/5 x plus 3 and y equals negative 5/3 x plus 5 are inverses using function composition. So this means to plug one function into the other. If I plug one function into the other, I can then simplify this, and if I get back just x, this shows that they are inverses of each other. If, however, I plug one into the other, it's called function composition again, and I get anything else but just x, let's say it's x plus 3 is what remains at the very end, then this shows that they are not inverses. So I have to get just x. First, pick one of these functions, and that's going to be our base. So we'll just, for simplicity's sake, let's just pick this first one. That'll be our base. Negative 3 over 5x plus 3. Next, I'm going to take the other function here, and I'm going to replace x in my base with this other function. So I'm just going to take this, I'm going to plug it in for x. So this will be negative 3 over 5, and then instead of x here, I'm going to plug in this entire thing, negative 5 over 3, x plus 5, and then I still have a plus 3 at the end. Okay, this will distribute. When I distribute negative 3 over 5, and I multiply it to negative 5 over 3, well, a negative times a negative is going to be a positive, and then I've got a 3 on top, 3 on bottom, as well as a 5 on top, 5 on bottom. All of this is going to divide out, and I'm just going to be left with x here. Then distribute negative 3 over 5 to 5. Negative 3 times 5. So I take this and I multiply it to just the numerator. That's going to be negative 15 over 5. So minus 15 over 5. And I still have this plus 3 at the very end. Well, 15 over 5 is 3. So this is x minus 3 plus 3. And then once I combine these, negative 3 plus 3, that's going to go to 0. I'm left with just x. So yes, they are inverses of each other. Okay, number 3 and 4. Solve problems 3 and 4 by taking the square root. So for number 3, I've got x squared equals 4. I'm ready to take the square root because x squared is isolated. So I'll say x squared here equals 4. And I take the square root of both sides. The square root of something squared is just that something, so this will just get x equals. Now, a lot of people are going to look at this and they go, oh, square root of 4, that's 2. And they're just going to put a 2. And that's half correct. Remember, I'm taking the square root, a variable is involved, I've got to have a plus or a minus. So there are 2 possible answers here. X equals positive 2, x equals negative 2. Okay, what about over here? 2x squared plus 5 equals negative 3. First, I have to get the x squared by itself. So I'm going to subtract 5 from both sides. This will be 2x squared equals negative 8. Divide both sides by 2. So x squared is going to be equal to negative 4. And then now that we're isolated, we can take the square root. When I take the square root of x squared, I get just x. Except over here, I get a plus or a minus, and then if I try to put this square root of negative 4 in my calculator, it's going to give me an error. That's because there is no real answer. So that means that my answer is going to be imaginary. I have to break up this square root of negative 4 into the square root of positive 4 times the square root of negative 1. That way, I can say x is equal to plus or minus. The square root of 4 is 2. And then the square root of negative 1, we say that that's I. Okay, that's our imaginary unit I, because we define I as the square root of negative 1. So my answer is x equals plus or minus 2i. All right, next one. Use the following models to solve problems 5 and 6. So I've got model A, the distance fallen in feet at time t in seconds is d of t equals 16t squared. And model B, the height in feet at time t in seconds, this is h of t equals h naught minus 16t squared. All right, so when do we use each of these? My general rule of thumb is use model A when you have an object that's falling and it's going to hit the ground. Use model B when we have a starting height and an ending height, and it's not necessarily going to hit the ground, it's just going to go from one spot to another. So for number 5, it says an object is dropped from a height of 30 feet. How long will it take to hit the ground? Okay, pause there. It's going to hit the ground. So my general rule of thumb again is to use model A. I'm going to write that down here. D of t equals 16t squared. Okay, then says, please give your answer rounded to the nearest tenth of a second. Okay, so 30 feet. It's falling from a height of 30 feet. Or in other words, d of t is the distance traveled over a certain amount of time. I don't know how much time has elapsed, but I do know that the distance that's going to be covered is this 30 feet because it's going to hit the ground. So I can fill in for d of t, this is going to be 30. So 30 is equal to 16t squared. Now, solve for t. So let's divide both sides by 16. This will give me t squared is equal to 1.875. All right, now let's take the square root. Normally, when I take the square root here, I'll get t equals, and then I would do a plus or a minus. Except because we're talking about time, it doesn't really make sense for something to fall negative, say, 3 seconds. So I'm going to reject the negative answer and just take my positive answer. When I take the square root of 1.875, I get 1.369. Now, it does say here, though, that I don't want this as my answer. I want to round to the nearest tenth of a second. So t is going to actually be equal to 1.36 is going to round up to 4. So 1.4 seconds. Okay, let's compare that to number 6 next. What does that say? Number 6, an object is dropped from a height of 98 feet. How long will it take to fall to a height of 12 feet? Okay, so we have a starting height and an ending height. You may also call this your initial height. So this is your starting height. And right here, 12, this is your ending height. That's important because we're going to be using the second model here, which is h of t equals h naught minus 16t squared. Now, what do these mean? H of t is your height after a certain amount of time, or in other words, the height that we're going to end at. In this case, that is 12. So 12 is equal to h naught is your initial height or your starting height. In this problem, that's going to be 98. And then I've got minus 16t squared. So let's solve for t. I'll subtract 98 from both sides. Okay, when I do that, I'm going to get negative 86 over here is equal to negative 16t squared. All right, then let's divide both sides by negative 16. T squared is going to be equal to, let's see, negative 86 divided by negative 16. That's going to be 5.375. And now take the square root. So I've got t equals, the square root of 5.375 is roughly 2.318. Except again, I want to round to the nearest tenth of a second. So this is going to round to 2.3 because of the 1, that's going to round down. So t equals 2.3 seconds. Okay, number 7. Solve 3x squared plus 18x plus 15 equals 0 by completing the square. Answers may be imaginary. All right, completing the square. The first thing I want to do is factor out a monomial if possible. So I've got 3x squared plus 18x plus 15. These are all divisible by 3 equals 0. So I'm just going to divide everything by 3 and see what that gives me. So dividing everything by 3, that's going to be x squared plus 6x plus 5, and that's still going to be equal to 0, because 0 divided by 3 is still 0. All right, next, I want to get the x terms kind of by themselves. So I'm just going to subtract 5 from both sides. Okay, this is x squared plus 6x, and it's going to be equal to -5. I'm going to leave a little bit of space right here. And that's because what I need to do is add b over 2 squared to both sides. So let's do that off to the side, b over 2 squared. Well, b is 6 in this problem. So I'm going to be adding 6 over 2 squared to both sides. That's going to be 3 squared. That's going to be 9. So I'm going to add 9 to both sides. Now, the reason for this is because on the left here, we've created what's called a perfect square trinomial. A perfect square trinomial, completing the square, factors the exact same way every single time. Let me show you. You're going to make a set of parentheses, and that's going to be squared. The first term here, x squared, you're going to take the square root and put it here. So the square root of x squared is x. The last term, 9, take the square root here. So the square root of 9 is 3. And then you're going to put a plus sign. You're going to copy this from the middle. If this were a negative, if this were minus 6x, then it would be a minus here. But since it's a positive, plus. And on the right side, you're just going to add these together. -5 plus 9, that is going to make positive. It's going to make positive 4. Okay, now we can take the square root. Square root of something squared is just that something, so it's going to be x plus 3. And that's going to be equal to plus or minus the square root of 4 is 2. Subtract 3 from both sides. And x is equal to -3 plus or minus 2. So what does that mean for having my two answers here? Well, -3 plus 2 is going to be -1. And -3 minus 2, that's going to be -5. All right, 2 more problems. Number 8, solve the system using any method. So that means that I can solve this system of equations using either substitution or elimination, whichever one you find more comfortable, do that. When I look at this problem, I see that I've got 2x plus y equals -1. I could easily subtract 2x from both sides, get y by itself, and then use that to substitute into my other equation. So I think I'm going to solve this one using the substitution method. So I'm going to start out with a over here, and that's 2x plus y equals -1. I'm going to subtract 2x from both sides. So this will make y equals -2x minus 1. And in this system, y is equal to this whole thing. So I might just put these in parentheses just to remind myself. Y is this whole thing, -2x minus 1. Next, I'm going to take the other equation, equation b, and I'm just going to plug this y into that equation. So I've got -2x minus 2y equals -4. Since y is equal to -2x minus 1, I can substitute this y here for -2x minus 1. That'll give me -2x minus 2 times the quantity -2x minus 1. And I've still got, this is equal to -4. All right, let's distribute. Negative 2x plus 4x plus 2 is equal to negative 4. Combining like terms, I've got negative 2x plus 4x. That'll be positive 2x plus 2 is equal to negative 4. We'll subtract 2 from both sides. $2x is equal to negative 6, and then dividing both sides by 2. I find x is equal to negative 3. Okay, next, I'm going to take this x equals negative 3, and I'm going to plug it into either of these equations. I could even plug it into this one, and that's fine. That might be easiest, so let's plug that in here. I know that y is equal to negative 2x minus 1. So I'm going to plug in x equals negative 3 here. So y is equal to negative 2 times negative 3. And then still have minus 1. So y is equal to positive 6 minus 1. And y is equal to 5. All right, last problem. Same type of problem, solving a system. This time I've got 3 equations, 3 variables. 2x minus 3y plus z equals 5, x plus 3y plus 8z equals 22, 3x minus y plus 2z equals 12. The first thing you should do is figure out which of these variables you want to get rid of first. I see here I've got a single z. Typically, I'm going to look for something that has just one of it. That's going to be the easiest way most times. So let's eliminate z. I'm going to multiply a by 2 so it matches with this 2z and c. So that'll be 2a and c we're going to combine. All right, 2 times a. So that means multiply everything in a by 2. That's 4x minus 6y plus 2z is equal to 10. C is going to be the same. 3x minus y plus 2z equals 12. Same sign, subtract. They're both positive 2z, so let's subtract these equations. This will give me 4x minus 3x is a single x. Negative 6y minus negative y. That's going to be negative 5y. And this is equal to 10 minus 12 is negative 2. There's a brand new equation. I'm going to give it a new label. I've got labels A, B, and C already, so let's call this D. And what I'm going to do is I'm going to do the exact same thing with a different combination. So I've already used A and C. Now I can do either A and B or B and C. Let's just do A and B. I can multiply A by 8 now to make this Z 8Z to match this one. So 8A and B. Okay, 8a. So everything in a gets multiplied by 8. That's going to be 16x minus 24y plus 8c, and that's equal to 40. All right, b is exactly as it is. X plus 3y plus 8z is equal to 22. Same sign, subtract. Let's subtract these equations. And we're going to get 16x minus x is 15x. Negative 24y minus 3y, that's going to be negative 27y. And this is equal to 18. So let's call this equation E. Now what I'm going to do with D and E now is I've got two equations, two variables left. I'm going to use these two to eliminate one more variable. So I see I've got a single x, so I'm just going to multiply this by 15 to match this 15 here. So that's going to be 15D and then E. So 15D is 15x minus 75y is equal to negative 30. And E is 15x minus 27y is equal to 18. And then I'm going to subtract. So negative 75y minus negative 27y is going to be negative 48y. And this is equal to negative 30 minus 18 is going to be negative 48. And now that I'm down to just one variable, I can divide here and solve for y. So let's divide both sides by negative 48. And y is equal to positive 1. Now what you're going to do is you're going to go one step back and you're going to plug into either equation D or E because that's what you used to find y equals 1. So let's plug this into D. D is x minus 5y equals negative 2. And since y equals 1, we're just going to plug this in right here. So x minus 5 times 1 this is equal to negative 2. All right, so x minus 5 is equal to negative 2. We're going to add 5 to both sides. X is equal to 3. Lastly, now that I know x is 3 and y is 1, I can take these and plug it into one of my original equations here, a, b, or c, to find the last variable, z. So I think B is going to be easiest. No, A is going to be easiest. So let's plug into A. A is 2x minus 3y plus z is equal to 5. Well, since x is 3, this will be 2 times 3 minus 3 times 1 plus z is equal to 5. So this is 6 minus 3 plus z is equal to 5. 6 minus 3 is 3 plus z is equal to 5. And then subtract 3 from both sides. Z equals 2. All right, and that's it for the midterm review. Hopefully this helps out. Please study up for the actual exam.